Dear students, this is Dr. N. Venkatachalapathi, Institute of Aeronautical Engineering. So I'm going to discuss on some of the gate problems in metal casting, especially the topic is solidification time. So when you're speaking about the metal casting process, the student think that it is a theoretical subject. There is no such type of formulas are available in this chapter like that. But especially when you wanted to designing of the casting process, so majorly when you're see the pattern allowances, some of the formulas to be there for applying shrinkage allowance, draft allowance, machining allowance, some bent allowance, and shaping and wrapping allowances. Some important formulas will be there. There you can able to before adding the allowance, before applying the allowances, what is about the exact dimension of the component. Okay, by before applying the shrinkage allowance, what will be the dimension, after applying the shrinkage allowance, similarly before applying the draft allowance, what will be the size, after applying the draft allowance, what will be the size, can be determined easily. So in this part 3, another important problem I'm going to discuss clearly to solve the solidification time. Okay, so generally, these are the some formulas. These are the some formulas for sphere, cylinder, and cube. So especially in for any important formulas, for you need to understand clearly. So then only you can able to solve the some good number of problems with these formulas. Okay. So first let us see the what about the sphere's formula. So sphere means obviously volume is 4/3 pi r cube. Sphere means 4/3 pi r cube, and the surface area, which is nothing but 4 pi r square. Surface area of the sphere is 4 pi r square. And if you take the cylinder, so cylinder means there will be one top and bottom circle, and the height pi r square h. This is r, this is h. So answer is pi r square h. Okay, pi r square h, and the surface area also 2 pi r square plus 2 pi r h. Okay, 2 pi r square plus 2 pi r h is the relation for this cylinder. And similarly, if you take the cube formulas, the surface area of the cube is 6L square. 6L square. So this is what about if you take the cube. Okay, so the volume is nothing but L cube. L means volume is nothing but L into L into L cube, and the surface area of the this cube, which is equal to surface area in the sense L into 2L plus 2L plus L into L. Okay, so L into L plus L into 2 into L into L plus L into L plus L into L. So obviously 3 into 2L. Okay, 2L plus 2L plus 2L. Okay, so obviously 6L square, totally 6L square is the surface area of this cube object. Okay. Okay, now look at in these formulas how you can utilize this case study problem. So this is the problem in a metal casting process, in a casting experiments performed using a certain alloy and type of sand mold. It is a performed certain alloy and type of sand mold. It took 155 seconds. It took 155 seconds for a cube shaped casting to solidify. So the cube was 50 mm. Cube was 50 mm on a side, and they determine the value cm, which is called the mold constant in a Coriolis rule. And then the second part is if the same alloy and mold type were used to find the total solidification time, TS. So total solidification time for a cylindrical casting in which the diameter R is equal to 15 mm and the length of the height is nothing but some 50 mm. So look at, already you know about the cube and cylinder. This is the cube. Whenever cube can be explained with the length width h, always it should be length width h. So all are equal, obviously that cube is equal to, okay, yeah, cube is equal to L into B into H. Okay, L H B or L into H into W. Okay, so where the surface area is 2 into LH plus H in L into W plus W H. Okay, so similarly, cylinder surface area of the cylinder is 2 pi r square plus 2 pi r h. Okay, 2 pi r square plus 2 pi r. Okay, so 2 pi r h. So the volume is almost all pi r square h. For cylinder, volume is pi r square h. The cylinder volume is the pi r square h only. Okay, so look at this problem. How do you solve? So in general, first you can determine the area. Area is equal to 6 into 50 squares. Okay, cube was 15 mm on side. So given data 15 mm on a side. Okay, 15 mm on a side. And another thing is determine the value cm of the mole constant in Coriolis rule. We are supposed to determine the cm mold constant or in a Coriolis rule. So that is what how that solidification time Ts is equal to some constant parameters. Solidification time is equal to V into V by volume by surface area whole square. Okay, so this is the general Coriolis equation where you can able to determine solidification time, where you can supposed to determine solidification time, and the formula which is obviously Ts is equal to what you call this B into volume by surface area whole square. Okay, similarly if you do this for some other college, this is called R and H. Okay, the surface area is 2 pi r square plus 2 pi r h. Okay, and volume is pi square r h. Pi square r h is the cylinder height, and the cylinder height, or we can also call it as a thickness. Okay, so this is what about the problem is given. So in these casting equipments performed using what you called certain alloy and type of the mold set, it took 155 seconds for the cube shaped casting to solidify. The cube was 15 mm on side. And how do we determine the mold constant? By using Coriolis rule. And what I supposed to if the same day alloy and mold type were used and the total solidification time TRS for a cylindrical casting in which the diameter R is equal to 15 mm and length is equal to 50 mm. Okay, so as we discussed earlier in this case, okay, so the cube is L is equal to W is equal to H, and obviously area is equal to 2 into LH plus 2 into LV plus 2 into and what you call WH. So volume is equal to L into H into W. So L into H into W, length, height, width. Obviously, what you call surface area is nothing but 2 pi r square plus 2 pi r h. So where the volume is pi r square h, where the volume is pi r square h. Okay. So in this way, first you need to understand the problem. Okay. So first, based on the problem, what is the data is given, and how do you apply simple problems by using this data and data book. So coming to the solution, you can see the uh, surface area 6 into 50. Okay, so in this problem solution, this is the problem. We are using Coronavirus rule, Ts is equal to B into V by SA. And apart from that, some determine the value of Cm and mole constant in the Coronavirus rule. And in the same day, alloy and mole type were used to find the solidification time, and TRS for cylindrical casting, in which the diameter and length. So diameter is what you call this 15 mm, and average length is called the 50 mm. Okay, so you can apply in this cylinder and cube also, where it is a uniform size and shape. L is equal to width is equal to height. Okay, so that the surface area is 2h plus 2h, 2 into LH plus 2 into LH plus 2 into what you call this WH. Okay, and volume also, which is equal to L into young into and H into W width. Okay, so here what I wanted to area and volume is given, and similarly this is for cube and this is for the what you call some tubes. Okay, so surface area is nothing but 2 pi r square plus 2 pi r square h. Okay, and most probably volume, which is given some n r square h. Okay, so this is the solution. How you can obtain area is equal to 6 into 50 mm size. Okay, and volume is nothing but 50 cube, that is 1,25,000 mm cube, and whatever the ratio between cm by. Okay, and here how do you determine the mole constant? First you need to determine the mole cost means here you can see the how you can prepare the mole cost, in the sense this cm is nothing but Telangana state divided by VIA. Okay, so where this formula solidification time V by A whole power square. So there is almost a molding constant is 2.22. Okay, 2.223 C, and mold constant 2.232, that that most. Okay, so in one more thing is, in a cylindrical casting, whatever the formula to be used for the cylinder casting, where r is 15 mm, h is 50 mm, and the area is 2 pi r square plus 2 pi r h. Okay, so 2 pi r square plus 2 pi r h plus 2m, what you call 15 into 50, that is 150. Okay, so this is 150, and that you can simplify it 6,618. Okay, 6,6128 mm square, and volume is V is equal to pi r square h, where pi into r means 15 whole square into h is what you call, how much you got, the volume is 35,343 mm cube. Okay, mm cube, and here volume by surface area is already calculated. So where you need to understand clearly about this volume, and V by A is nothing but 5.77 V by A, that is volume by what you call A in the sense solidification time, etc. Okay, and V by A is equal to 35.323, and this value, uh, tensile strength, tension, okay, 2232 divided by what you call 2.232 into 5.77 whole square, that almost 74.3. Yes, and 124.5. Okay, 124.5. So this is the problem to be discussed clearly in the examination point. Okay, this is what about how we are supposed to explain the solidification time in part 3. Okay, so these type of simple problems may ask in the examination. So if you take a cube, means L is equal to W is equal to H. Similarly, a cylinder which is having surface area and volume pi r square H. And what I wanted to suppose to explain here, R is equal to 15 mm and length is equal to 50 mm. When you substitute here, obviously you can able to improve better for the improvement. Okay, and the first thing is here cylindrical casting, R is equal to 25 and H is equal to 50 mm. You can substitute this into the equation 2 pi r square plus pi r H 2 pi y square. Okay, plus 2 pi into 15 into 50, that is equal to 6126 mm square. Okay, where V is equal to pi r square H and pi r square H, that means to 6.43 m cube. Okay, volume. So that volume is surface area. Obviously, it's 35. Okay, 3.43 mm cube. Okay, and V by A is the volume by surface area. Obviously, 94. Okay, 35,343 and 66 what you call this solidification time in this Coronhouse rule. How you can able to determine any mixing dimension, etc. These are some following references we have referred to put the problems effectively. Need to understand clearly in this subject. Thank you, student. I hope the student can understand clearly about this second module also. In the next module, we can able to discuss another case study problem. Okay, so thank you.
Like, share and subscribe. Hit the bell icon for more updates.